Maximum kinetic had to be down here at the bottom. Now, maximum potential energy is always where?
At the top.
So it had to be up here at number 3. Now, if you labeled it that way, you got 2 points. This was the question that had the absolute least points attached to it. Now, the other 2 required you to draw in some arrows. And this is where a lot of people had trouble and why they didn't get points. And it's one of the reasons why it counted the least number of points on the quiz. So you have to draw in arrows labeling where kinetic and potential energy are increasing or decreasing. And I let you draw in the arrows any way you wanted to. Okay? So I drew the arrows on this graph. Since I drew arrows this way, you can label it any way you want to. So if I draw the arrow this way, which one do you want to label here?
PE.
Okay, so PE would be doing what on this arrow?
Increasing.
It's increasing because height is going up. All right, so on this arrow, what do you want to tell me?
And KE.
All right, so KE would be doing what on this arrow?
Increasing.
KE would be increasing because what's happening to the speed of the ball?
Decreasing. Going down.
It's going down, so the ball's going down, so speed is doing what?
Speeding up.
All right, speed is increasing. Now, this is the connection that you guys have to make. Anytime speed is increasing, kinetic energy is increasing. Anytime height increases, then potential energy increases. As long as you have that connection in your head, you should be able to answer those anytime you want to. But a lot of people don't have that in their heads. Now, the things that I didn't take is people wrote kinetic energy and they drew an arrow that way. I have no idea what that meant. Kinetic energy is increasing in which direction? Up or down? Okay? Now, you probably knew what you meant, but I didn't know what you meant. So, I mean, it was only a 1-point question, so I took the 1 point because I didn't know what you meant. It's not like you lost 10 points there. All right? So, when you're talking about up and down a hill, you got to draw the arrow going up or down when you say it's increasing or decreasing. Okay? Questions. These are for response questions next week on the test. Not the benchmark, the regular test. And that will be the first test of the quarter, most likely. That I'm going to make it the last test of this quarter. But if I make it the last test of this quarter, it does not give you much time for makeup. Because it honestly is probably going to be at the very end of the week, which is going to put it as the first test of the new quarter. Which I hate because this test always sucks. All right, questions about the opening. All right, so that's opening number 2 for those of you who've been absent. Make sure you get yesterday's if you were absent. You missed a quiz and you missed a lab. And the quiz and the lab have to be made up before the end of the quarter if you plan to. All right. We finished the lab yesterday. I've not finished grading it. I've started it. I'm still on everybody's page 1. I'm bogged down in marking -1 for units for not there and for the people who didn't show me work. It's taken me forever to grade that front side because half of you did not do what I told you, so I'm too busy bleeding on papers. Quizzes are graded. They're in Power School. Okay, so if you want to see your grade, that's in Power School. I'll return those later today or tomorrow. Now, if you will, find your notes. We're switching gears to heat. 4th period is still in the lab. They didn't quite finish it yesterday. They took longer on the quiz than y'all did. I didn't think that was possible, but apparently it was. So we're moving on to heat today. Now, heat is not a very long unit for us.
Yes, I got a note this time. I always do.
Except when you go by the cafeteria.
Oh, we did.
No, you didn't. You gave them the ROTC. Which probably means you starving because we didn't get to go by the cafeteria.
Yep.
You survived. Think of it as a weight training program. All right. So, the reason I do energy with heat, and I don't break heat up into a separate unit, is last week we talked about the 5 forms of energy, right? Well, heat is one of our 5 forms of energy. So I go ahead and put it all together in the same thing. So heat is thermal energy. What were the other 4 types of energy? Because some of us didn't know this yesterday on the quiz. What are the other four types? If heat is thermal energy, what were the other four types of energy? Chemical is one. Thermal is the one that's on the board. So electromagnetic and chemical. Nuclear and mechanical. Electromagnetic is already named, but that is one also. All right, now, when we talk about thermal energy, does anybody remember what I said thermal energy had to have to be thermal energy? Nope. There's a key word I gave you. Anybody remember what it was? No. Let's start with an I.
That's what he knows.
I don't know. I could have told you. Oh.
It's all right. We'll get to it. Now, we're going to talk about heat today, or thermal energy. Now, in order to talk about heat, we're going to talk about types of heat transfer. Now, what is heat? Heat is energy, first of all. So, let me cover up these last two lines. Just a second. All right? Heat's energy. Dig into something y'all learned in another science class. Does energy have a mass?
No.
Does it take up space?
No.
No. It's not matter. Okay? We can't find the mass of energy. We can't find the volume of energy. We can't touch it. Okay? So it's not matter. Back in, I'm just guessing, maybe late elementary school, maybe even middle of elementary school, but certainly by 4th or 5th grade, your science teachers started talking to y'all about what is matter and what's not matter. Okay? Your science teachers talk to you about the fact that things that take up space and have mass are matter. So like your desk is matter. It has mass. Takes up space and put it on scale. Your calculator is matter. Takes up space. Has a mass. We take up space and have a mass. Okay? We're matter. Is heat matter?
No.
No. Why?
It don't take space.
It doesn't take up space. We can't bundle up some heat and stick it on a scale. Does that make sense to everybody?
Yes.
Okay? We can't put it in a container and put it on a scale. Now, is gas matter? This one always confuses people. Is gas matter?
No. Yes.
I'm asking. This one bothers people. Every time I ask it, I get a bunch of different answers. Does gas matter?
Wait, what?
Yes, since it takes up space.
Why does it take up space, Raul?
Because it's air.
Okay, so does air matter? Does it take up space?
It's a little.
I'm asking Raul.
Yes.
Okay, give me an example of something that takes up space. It's a gas.
Something like air, in the air, like gas.
You're not wrong. I just want a
Because it has
concrete.
molecules, that's why it takes up space.
I know. I just want an example I can relate to. He's not wrong. Okay, well, give me an example of a gas that takes up space that you guys can relate to. He's right. Something y'all can relate to. And that's not a gas, by the way.
That gas, the gas that they use in hot air balloon.
Yes. Okay. The gas that blows up the balloon in a hot air balloon.
Helium.
Helium balloons are gas. All right. Most of us don't necessarily buy helium balloons. Most of us are kind of cheap at birthday parties. What do?
Blow it up.
We blow it up. All right. Now don't disappoint your biology teachers. What kind of gas can we put in balloons? Y'all biology teachers over there thinking, hey, I didn't need nothing in that glass. What kind of gas do we exhale? Carbon dioxide. So, yeah, like two people. The rest of y'all said oxygen. All right. Y'all breathe in oxygen. We exhale what? Carbon dioxide. So if we blow up a balloon, we put carbon dioxide in the balloon and they lay on the floor. Because carbon dioxide is heavy. It's got a higher density, so they sit on the floor. If we want carbon dioxide to be in the air, can we blow it up with carbon dioxide?
No.
No, we got to go to the store and buy what kind of balloon?
Helium.
Helium balloons, because helium balloons are less dense. They will float. Okay? Those are examples of gases that have volume, and we could put them on the scale and find their masses. Okay? But heat has no mass. It has no volume. Okay? So it's not going to be matter. Does that make sense?
Yes.
Okay. It's just energy. Now, here's the second part of it. It flows between two samples of matter. Now, when you guys come in here, every day y'all say, cold in here, Miss Wall.
It is.
Okay? I'm not going to disagree with you. Okay? I'm wearing my fleecy today too because I think it's cold in here. Okay? Now, you come in here with your bodies. Whether they're warm or cold doesn't matter. But you come in here. Is your body at the same temperature as this room? No. Okay? Heat will flow between your body and this room. Keep writing. Catch up with me. We're going to talk about it. All right, you got it? So every day y'all come in here. You have a body temperature, whether you think it's warm or cold. You walk in the room, you know what? Cold in here, Miss Wall. Okay? Your body temperature walks into the room you perceive as cold. Heat flows between your body and this room. Now, if your body is warmer than the room, heat flows between your body and this room. What does your body do to my room?
Heat it up.
It heats it up. Okay? Every day. 20 of y'all come in here with your warm bodies. Heat flows from your body into my classroom, and it heats my classroom up. At the end of class, y'all leave, take your heat with you, and what happens during lunch?
It's colder.
It gets colder. Fourth period comes in, and what happens? They're here going, cold in here, Ms. Wall. And there's 20 bodies. Well, they don't all attend, so about 15 of them come in. And they go, cold in here, Ms. Wall. So their bodies come in and do what?
Warm it up.
They warm it up again. Okay?
And
Because
press.
heat flows from the warm body to the what body? To the cold body. We're going to write that down in a minute. Now, and the reason it flows is between a difference in temperature. Now, that's going to sound sort of weird to you. But you guys came in with your warm bodies and sat in cold desks. Now, the heat flowed from your warm body into that cold desk, right?
Yeah.
It did. Now, when you get up, the seat's warm.
Yep.
Any of y'all ever sat down into a warm seat and been like, ooh, somebody warmed the chair up for me?
Yep.
Yep. Don't like to give up your warm seats. Okay? Now. All right. Which way does heat flow? All right? If you have an ice cube sitting in your hand, everybody knows the answer to this. What happens to the ice?
It's gonna melt.
It's going to melt. Okay? So, what way does heat flow? I always get that answer. It's usually out or up. What direction does the heat flow?
Into that nut. Down.
It's not down, it's not up, it's not out.
And to the cold object.
Okay? So it flows from the where to the where?
From the warmest to the coldest.
All right, from the warm object to the cold object. Okay? That's the part you need. Okay? You don't have to write that up there. All right? You need to write this part right here. All right? From hot to cold. If you don't want to write hot, you can write warm to cold. So, when you sat down in that cold chair, your body was warm. So heat flowed from your warm body into the cold chair. If we go home today and we cook a pizza, okay, get out of the freezer, put the frozen pizza in the freezer. Heat travels from where to where?
Frozen pizza.
All right. Well, we'll put it in the oven. Did I say put it in the freezer?
Yeah.
Okay, put it in the oven. We're not getting far. We'll put it back in the freezer. All right, put it in the oven. All right, so we put the frozen pizza in the oven. What direction is the heat going to flow?
Like from the oven to
From the oven to the pizza. All right, we go home today. You accidentally leave the front door open.
oh god.
Okay,
From the inside to the
No.
outside.
what direction is the heat going to flow?
Out of the outside.
I mean, like from
Where's it warmer, outside or inside? Say
outside,
it's warmer.
Inside.
Hopefully, it's warmer in your inside.
right now.
Right now, so
Yeah, something
heat's
like
going to flow from the inside to the
So
outside.
like when your parents say, "Don't leave the door open."
You can let all my heat out, right?
Okay.
Let heat out.
Exactly. Now, they are letting the heat out. Now, in the summertime, when your parents say, I'm not air conditioning the outside, are they really air conditioning the outside?
No, the
No.
outside is mixed.
They're really letting the heat what? In. Now, don't be disrespectful to your parents and correct them. But technically, they're not air conditioning the
My
outside.
house is
They're
always,
letting the heat in.
my house is always cold.
All right. All right, we did that.
My house is freezing even.
All right, we did that one. We did that. We did that. All right. All right, we're to where I want to be for the scavenger hunt. One of those, everybody. I didn't think they're on the
Stop dropping it.
All right, Carl, we're gonna do this on the computer so we can try to log in and see what happens.
Something like
I have a
that.
question. Yes, you have. So what is it? You got two of them.
That's my first. Bro, Logan knew it.
Yes.
I said my first. Hey, class.
Hey,
Tell it, man.
We're gonna do the three methods of heat transfer, the three methods of charging. Charging, static electricity, which is next. Alright, turn out the paper. Alright, grab your laptop. I don't think I put it in Google Classroom, you can check. But this one's one of those that's pretty easy to find. Well, I don't know if I put it in Google Classroom.
Alright, y'all was dead.
He can get 13 for y'all. You know.
Get your chips out.
Right.
I'm just playing.
Excuse me, baby. What?
You know,
Don't say baby Brown Smith. Talk about some BB Beans. I love them.
Who's a bit?
Love them.
I said that last year, man.
Why go get Billy Lee?
That's it, Burger King. No, get it.
Free. What's wrong? Don't play.
No, I didn't give you anything helpful on this one.
Dang it, Miss Wall.
So you can use whatever you want. I told you, this was pretty easy.
So this say,
Everything.
so what, Naya?
Taking an hour
See
on
my
this.
phone, I don't know, but it's the same,
No.
I see you, but. Come get your. Did you figure out how to do this? You got your man in front of it.
I don't know what you're talking about, right here.
He said what? He was scared, look, he was
He
scared.
made it
to
clear.
take the picture. He was scared to take the picture.
It's all right. So you
I was like, this is so fun.
and
Why you do that? He was scared.
It was scared of you. I don't need access. Bring it in.
I go at like.
275.
I saw y'all last, I said, come on. Had the piece of love.
Come on, who gets what's like a computer?
Bob, man, leave. Oh, this is embarrassing.
Blake, what are you doing?
This embarrassing. Tell him to leave.
That's how my feet.
There you go.
That is scary.
Oh, no, no, watch. While we're here. You don't need it today, but let's go ahead and do that while you're here.
Leave my man alone. He was taking it out. Okay. Gave him some nice to put to sleep.
Oh my God. There's Night Quill. Come on, girl.
Hey.
There you go.
Oh, he was talking when he woke up.
You can go to any website you want, you can fill in your parts on that chart, on the 3 types of heat trace.
You should put the feeling wheels on. That's all.
Jacob, why are you back there with William?
I told you they best friends.
I need to know where we going.
You may go to any website you like,
For what?
1, 2, 3.
on the Lord.
Oh, okay.
17.
Use fucking really computer to find what you need.
Oh, so far, like,
That's the,
Production.
that?
yeah. On the computer.
How did it
Well, you ready to eat that?
That's now. Yeah. You should have seen that picture of him. Male, convection and conduction. Who was you seeing, Bree?
Nathaniel, why are you back there?
You should see that picture of him and male.
No.
Like, what is it?
You and Jacob come back to your seats. First of all, William does not need help, and if you two are stuck, I will be glad to help you. So you two come back up here and do your own work.
Don't do that, man. I'll get good. I'm going to not jail for the baby. Let me look at try to touch my butt on that shoe. But she probably will put it back in this good.
Everything. Good, that started You just draw one picture before?
Where we at?
Right here.
Let me see what it says. I forgot what this was for. Pictures, yes, one will be fine for the pictures. Yeah.
I did.
Please, sit down. Or sorry, I'm checking. Sit down.
I was up. Hey,
I am right here. I can stop grading these papers if he has a question.
He asked me where.
Because they're not that exciting.
Sorry.
No, that actually look nice. It don't look that bad. Maybe you, but it look like an ass. Oh, it's already Sunday. They gotta have
Man, dude, that's too small for this.
a calculation.
It is.
Yeah, no, cut your beat.
They use the same picture.
Anybody have a question?
Are solar panels, can solar panels be exempt from radiation?
My pictures are so.
It's okay. My pictures on the board don't look that great either.
But
Yeah, girl.
People with light bulbs really.
Would be good.
Depends on what you're doing with it. If you're just looking at it radiating heat, that's fine. If you're touching it, it can be conductive. It depends on what you're using it for.
But, okay, what if, like, the heat from the sun over your face, is that radiation?
That's radiation, yeah.
it's fine.
Yeah,
Could a blood trial be convection?
yes. Can be radiation or convection, but for the most part, we use convection on that one.
Turn it.
Oh, no, you just show it to me. But yes, you have to show it to me. Gotcha. Okay, so.
The scavenger hunt.
Those of you still working, you can't finish it up. Nope, hang on, I'm talk about it. What you got? All right, looks like I see Raul,
Oh, mine's finished.
Logan, Nathaniel, and Alexis. Alexis, Raul, and Logan.
Pretty sure. That's already like that.
Oh, you're in town? I already got your What you got? All right, so down to Alexis and Logan. Alexis, you're done. Let me see the paper. You're the one over there signing deeply. What's that for? What's going in the great book? I don't ever want to hear criticisms about my artwork again. Like ever. If that's supposed to be a hand, you better tell me how fabulous my artwork looks on the board every time I draw.
But I can tell what it's just.
No,
Yeah, go shadow free that hand. And then tell her that tell her if she can be critical about my artwork.
Give us fingers.
I'm not even sure they're fingers.
They probably will scribble. Probably scribble. What the world?
You know, laughing at
Logan, you're the only one I'm waiting on.
He ain't even halfway done.
I am. What?
Now.
Oh, no, we're not waiting on you. I just bring me yours and let me see what you got. I give you a grade with what you got. I don't know what you've been doing over there, but it's not my work. Let me see it.
No.
Yes,
Oh, John. Yeah, but I still
because you've clearly been doing somebody else's work and not mine. I give you 70. Where's Mr. East over there? I need to see his too.
Oh, John.
Yeah.
Johnny.
Go on, Mr. East. Let me see what you got. Okay, let me see it. We ain't waiting on you any longer either.
You said what?
I said, we're not waiting on you any longer either.
What?
Yeah. All right. So let's see what you came up with. All right, because we're going to practice some of this stuff in a minute. Now, with the first one, I want you to flip your paper over because we're going to write down two things that you should also remember from another science class. Because all of this stuff that we're actually doing right now is review. It won't be till we get down to number 7 that we really should talk about anything that's new. All right, so for conduction. All right, what's the key word that you guys should have used? Because you can write down any definition you want for conduction. All right, the one I chose was heat is transferred through a substance by direct contact. Okay, you don't have to have the exact same thing I wrote. Y'all should be looking at your paper. Why are y'all writing down notes? I want you to look at the paper you just used.
I just said flip it over.
No. I'll tell you what I want you to flip it over and write something else. Not there yet.
Oh, okay.
It's on the next slide. Okay? All right. So when you look at what you wrote for a definition, are you somewhere similar to what I have?
Yeah.
Okay. So what's the key word that you might have picked? Okay. What does direct contact mean?
Rubbing against each other.
All right. What did we just do?
Touching.
That's the word I would pick. Okay. So for the key word, I would have picked touching. Okay. This is what the key word is. Now, direct contact's a really nice fancy word, but all it means is you're touching. In order to heat by conduction, it has to touch. If it doesn't touch, you're not heating by direct contact. So yesterday, I did lab in my first period class, and I had all that stuff out. And unfortunately, one of my students burned herself 3 times. I know. So she was transferred heat by direct contact, unfortunately, 3 times. So once she did that, all I could offer her was some burn cream and a Band-Aid. Okay? I couldn't fix that for her. Now, I told her and the entire class, if you suspect something's hot, to put your hand near it and see if you felt some heat coming off of it. Now, what kind of heat transfer is that based on what you just did? If you put your hand near it and you felt some heat coming off of it, that's radiation, okay? Unfortunately, some of them weren't savvy enough to do that, and I don't know if they just got rushed or they thought it was okay, and they just grabbed it, and then they were like, ah! And then they let loose of it really, really fast, okay? Metal and ceramics get hot really, really fast. And so once it got hot, they let loose of it pretty quickly, okay? So, but when you touch something, it's going to heat by direct contact. So anything that you touch, that's got to be conduction. So what kind of examples could you have put there? For conduction, what kind of examples could you have put?
Cheese melting on a burger.
All right, cheese melting on a burger.
Soup. Hot on the stove.
Hot on stove.
Heating a tin
Heating a tin can.
Hot
Hot coffee in a cup. What?
Touching the engine, running engine.
Touching a running engine. I don't recommend that one either, but people do it all the time.
can.
Say what?
Ice cooling.
Ice cooling. I can't hear you.
When the ice melting down your hand.
Yes. Okay. What else?
Put a metal spoon in some hot water.
All right, touch the stove and getting burned. Now, instead of just touching the stove, that does, hopefully y'all don't do that a whole lot. But y'all might have this experience. How many of y'all have ever left a spoon in a pot, not paid any attention, come back to stir the pot, and then grab the spoon? That happens a lot, okay? I don't do it as often now as I used to when I was younger, because I'm smarter now than I was when I was younger. Aside from that, I bought spoons that have wooden handles, so that the metal's in the pot and the spoon has a wooden handle, so that I don't get burned nearly as often. Okay? That's where I'm going with this, then we're going to write on the back. Okay? Okay. I can't fix stupid. And that certainly borders on it. Alright. Now, what state did y'all find that conduction works best in? Because y'all put that as the key word. What state does conduction work the best in?
Solid material.
Solid materials. Okay? Conduction works the best in solid materials. So for all of you who are like Alexis here, and she put her keyword is solid, alright, put works best in solid under that. Okay, so if you put solid there as your keyword, write that it works best in a solid. Because conduction works the absolute best in a solid. It doesn't work best. Convection, first of all, convection does not work in a solid at all. We'll talk about why in a minute. Conduction works the best in a solid.
What is a heat flux? 'Cause that's what I got for all my conditions.
I have no idea.
I got a heat flux.
Okay. I would assume that it's going to vary. The heat's going to change if it fluxes, but beyond that, I don't know.
I'm looking it up.
Okay, go right ahead.
Solid, they can't work because they can
carry loads around.
Well, convection has to allow flow. You have to have the movement of currents, and a solid cannot allow for the movement of currents because the particles are in fixed positions. All right, that's not what I want. So I need to add a board here. All right, this is what I want you to write on the back. So in best guess would be middle school. Y'all talked about a conductor and an insulator. And we're going to talk about this again when we do electricity. One of the things about heat and electricity is they have a lot of similar topics, okay? And so once we finish this topic, we're going right into electricity. And you're going to find a lot of the things we're talking about now overlay themselves right on top of electricity. And this is certainly one of them. Now, does anybody remember what a conductor and insulator are?
Yeah.
What is it?
A conductor takes heat and an insulator keeps it trapped in
Okay.
or out.
So, a conductor allows
Heat pass.
for heat to travel through it easily.
Insulator keeps it out.
Okay. An insulator will not allow heat to move through it. Now, because it will not allow heat to move through it, using Jacob's words, all right, it keeps heat in or out, which is why things like Ozark cups, Yeti cups, cooler type insulating cups are very popular right now. So if you want to keep a drink cold and you want it to keep ice in it all day, you can buy an insulating type cup because it keeps the cold in, or if you're a coffee drinker and you want the coffee to stay hot, you can keep that hot liquid hot all day because it keeps the heat in, okay? That's the function of an insulating cup. Now, the reason that I brought this up is because we're talking about conduction. Now, what types of materials are conductors? What allows that heat to pass through it very easily? So when you think about pots on the stove, silverware that we use to stir with it burns the fool out of us when we forget it and leave it on the stove. What kind of materials are those? They're metals. Okay? Say it loud enough I can hear you. You know I'm getting old. Okay? Conductors are metals. All right? So, if it's a metal, it's a conductor. So what kind of things are insulators going to be?
Wood.
Okay? That's one example.
Plastic.
Plastics.
Cloth.
I was gonna say.
What? I haven't used any of that recently, but. Huh? I would almost bet y'all that y'all have some of this at home in the kitchen. Probably have some spoons, some spatulas, something made of this. Starts with an R.
Oh, what?
Rubber?
Yep.
I understand.
Okay. Now, this whole grouping of crap that y'all have just given me is the anti of metals. What do we group them and call them? There you go. They're called non-metals.
Yeah.
Okay, so as a subcategory, instead of, listing all of that stuff, you can just call them, they're not metals. Metals are conductors. If they're not metals, they're what? If they're not metals, they're called what? They're insulators. Good, Sierra.
Styrofoam.
Okay, styrofoam would fit up here. Yes, styrofoam is an insulator. Okay, so any of these things we put in green down here are non-metals. Non-metals are insulators. Metals are conductors. That make sense?
I was gonna say styrofoam. but-
Styrofoam would be right. It's an insulator.
Unless I'm stupid, sorry.
Okay? Everybody with us? All right, what about convection? Can we go to that one? Oh, you need me to wait?
But you know, let's say I said this one.
Okay. All right, so convection. All right. I put this heat energy transferred by up and down movements of convection currents. Now, again, you don't have to have the same word, same wording. You have something similar.
Oh.
It's all right. You got movement of molecules. You're in the same ballpark. All right. So
Definition of heat flux.
I don't know what's the heat flux.
It says, heat flux and thermal flux sometimes also referred to as flux due to low energy time, and that's why it's used. Yeah, that's a lot. I think
Mine's
it's
all
very simple.
different.
Yes.
Okay. Anyhow, so what would a good keyword be here? All right. What else?
Gases.
Gases, liquids. All right. So if you want to put liquids and gases as a keyword, there's nothing wrong with that. All right. So liquid, gas.
Heat position.
All right. I would even argue currents. Now, what kind of examples did you put here then based on that? Blow dryer. Because again, it's moving what? Moving. Yes, but it's moving air. Air's what? Air's what? It's a gas. Okay. What else did you put?
Soup. Boiling water.
Boiling water. Water's a what? It's a liquid. What else? I guess you could put soup. Soup would be a liquid. As long as it's not real chunky. Say what?
Lava lamp.
Lava lamp. Lava lamps are liquid. You see the stuff moving up and down. Now, the biggest thing that I would tell you about convection is you have to have the movement of liquids and gases. There has to be movement of currents. For the most part, in here. The air just cut off. I don't know. Maybe they're cutting the air conditioning off and turning it back to me. All right. When you look at even in here, okay, see these vents where there. That's where the air comes out. Okay. There's 4 of them, and then you have these things in the middle that are the return vents. The air comes down. Those 2. Air goes back up. Air comes down and goes up. You get a draft situation. That's convection current. It's called central air. Anytime you have central air in a house, you're heating by what? Convection. Okay? Do y'all have central air in your house?
Yes.
You have heat and air by convection. All right? Now, if you have a wood stove, if you have a kerosene heater, and you go, let's say Alexis's wood stove, and you go sit in front of it,
That's
you're
radiation.
heating by what?
Radiation.
Radiation. But if you have air that comes down and goes up, down and goes up, you're heating by convection. All right? If you go sit in front of a fan, sit in the chair and let the fan blow on you, what are you heating and cooling by?
Radiation. Wait, what?
You got a fan.
Man, that's radiation. That's convection, my bad.
Convection is currents. Okay? Now, how do you know boiling water is convection? What do you see in the water that tells you you're heating by convection?
Current, like woolen bubbles.
The bubbles. The bubbles moving up and down, so you have convection. How do you know the lava lamp is convection? What do you see in the lava lamp? First of all, you have to have seen a lava lamp to know how this works. Has everybody seen a lava lamp?
Yes.
Okay. How do you know it's a lava lamp that's convection?
The slime moves up and down.
The slimy stuff inside goes up and down. That tells you it's convection. Okay? But there has to be the movement of currents up and down. Now, that's why I said solids can't be what? Solids can't be convection. Okay? Because can you have stuff going up and down in a solid?
No.
No. All right, the last one, radiation. I don't think I need anything there. Nope. I don't. Radiation. Now, this one, most of you guys had electromagnetic waves, which is fine. There's nothing wrong with electromagnetic waves. However, what's the key word that I have up there? Any idea what the key word is that I have in my definition?
Empty space.
Empty space. Okay? Basically, to be radiation, it can't do what? Can't touch. Okay? You cannot touch. All right?
I got electromagnetic waves.
And there's nothing wrong with electromagnetic waves because radiation is going to take place with electromagnetic waves. But with electromagnetic waves, there's no touching. Okay? So when you sit outside, white people are the world's worst for this. Sit outside and bask in the sunlight like we're going to get tanner. I'm going to get skin cancer. So we sit outside and wait on skin cancer to arrive. We are tanning ourselves by radiation. All right?
So when you get sunburn, that's radiation.
Sunburn is radiation. All right? When we sit in front of the fireplace, we sit in front of the kerosene heater. We sit someplace, hopefully.
Bonfire.
If y'all ever go sit by the stove because mom's cooking dinner and you're like, you're cold and you go stand by the stove,
I stand by
that's warming yourself by radiation.
We used to
All right? Nobody stands by the microwave. Why don't we stand by the microwave?
Because they don't have radiation.
It doesn't get hot. Okay? We stand by things to get warm because that's radiation.
When we did
We didn't have what?
That's it.
Okay?
They don't know the struggle like that.
Right.
Please. I did that when I was younger too. Now, what examples did y'all write down for radiation?
Iron stove.
The iron stove,
Standing near a bonfire.
opening your door. If it's warm outside, would be great.
Sun.
Today it would not work very well. Standing in the sun,
Standing by a bonfire.
standing by the bonfire.
Fires.
Any of y'all actually done that?
Yeah.
Yeah.
Okay. What?
Standing by a freezer.
All right, standing by the fire. Don't touch it. What else?
Standing by the freezer when you're like really hot. Like I do that in the summer. I'll go like stick my head in the
The sun shining.
All right, standing by the freezer. All right, what?
freezer. You get colder.
Yeah, but you'll melt what's in the freezer. Say what now?
The sun shining towards her.
The sun shining towards the earth. It doesn't have to be about us standing out there. It can be just warming up the earth. All right, anybody else got something different than what we've already yelled out?
Heaters.
Huh?
Heaters. Like
Heaters, any kind of heater. If you're standing by it, it doesn't even have to be really standing by it. It's just warming the room up. That's radiation.
Some ice.
Yeah, we've heard the ice examples. All right, let's practice. All right, I'm gonna make Alexis hand this out. Why not? Are you injured?
I'll hand them out.
Here, Jacob. All right, while Jacob's handing out the papers, y'all put your laptops up. This is short and easy. And you gotta put your laptop up and stop lying. Go put your laptop to the cart. Well, I put it up for you, let me think about it.
So what if I mess up?
Oh no! I can't put them on that top. You must be crazy.
I want my finger to
Yeah,
touch
grab
my
it.
arm.
You already know his name.
You know what that is?
No, I'm not putting your laptop up.
I will physically don't stay around you over here.
Well,
That's just being like.
Roll all the way over there.
Okay, now you said I won't. Huh? There you go.
Today's 8. Today's the 18th, right?
Yeah.
Today's the 18th.
Okay.
Do we take it? We already talked about it. We can take it. We already talked about it. I'm getting ready to do it, but I'm getting ready to give you some instructions.
I was asleep when you was talking about that.
Bro,
We're getting ready to talk about it.
you're confusing.
All right. With the exception of the couple of people who are putting up the laptops. All right. So part one. Part one, you're going to either tell me whether it is a description of heat or it's not a description of heat. So you can use the letters, or we are using the letters H or N. If it is heat, you're going to write H. If it's not heat, you're going to write N. So in question one, heat is an invisible, weightless fluid. Is heat matter?
No.
So what are we going to write for number one?
N.
N, because we just said it's not matter a few minutes ago. Okay? So you're going to write N. All right? Now, and number two, have you heard me use the term caloric today?
No.
So what does that tell you about number two?
No.
It's not heat. You get the drift? All right, and part two. So in part two, I'm asking you, are these things insulators or are they conductors? So if you look at number one, is air an insulator or a conductor?
Insulator.
Is air metal?
No.
So what would it be?
Insulator.
It's an insulator, right? That's why people tell you it's a layer. When you go outside, air gets trapped between the layers and provides warmth. All right? In the bottom section, that was dude warming himself in picture one. Conduction, convection, or radiation? Radiation, not touching. Everybody get how to do the sections? All right. We're going to go over this before the bell. Everybody got the idea?
Yep.
All right. It should be easy. Now I'm going to fix the mess that's probably in the car.
He can only transfer one way.
How many ways do we say we transfer heat?
If it describes each page, right?
I know you do. I eat vegetables. I eat vegetables. Sorry. I eat Oh, nobody's honest. Okay.
Okay, since it's touching the fire, that'd be.
Some idiots actually touching the fire.
They're slow.
Extras or handing a fire.
No, it's.
It's like an iron.
That could actually be two answers.
Okay.
What opens to the
It's not
That's
radiation.
convection.
Convection. It's got holes.
You said a hair dryer can be conducting?
Hair dryer's never gonna be conductive.
This
Okay,
one,
so
right?
would that be radiation?
Depends on the kind of toaster.
It's literally just like 2 spots.
Can be 2 inches also.
Radiation.
That's one that can be.
Here.
She appears to be touching that
Are
one.
you there?
Yes.
No, on my 30 day. Hey.
Looks like she's touching.
Very nice. Hey.
Yeah, copper's a
So,
bit.
Colonel.
What?
Anybody else have a question?
No. No.
Yeah.
Yeah.
What's the fourth one?
About what?
My mom won. Like you. What you call it?
That's showing an event on your house, but he's your air conditioner.
With the gradation.
I just come, why did you come and say hello?
Cause I didn't know if it was here.
I'm not talking to you. I haven't said it. What did you got my shirt?
That's the one who cares. I promise it's not me.
Oh, this one.
That is air coming out of the vents. Generally speaking, when you're looking at pictures and you're trying to figure it out, if you see air or arrows, I would assume arrows are too much.
This is warm, right?
That one, you could look at it two different ways. Generally speaking, a lot of people put radiation because they are sunning themselves. The other answer could be sitting on the wall.
What? Colder? No.
What?
I didn't send warm up. Warm up over your fashion.
Yes, there was.
I put, both. Right.
Oh, yes. That's wrong. It is called.
I think that mentioned we talked about it in the last meeting.
Friend, you trying to get a friend? You want my pencil, friend?
Warmer than water.
Friend, you have a pencil.
I meant that.
It's a convention.
You want to do?
Nope, we're going over it.
What is
Raise it.
The flame is touching.
But it's.
And the bubble.
He is invisible, like.
The bubble.
Oh, hurry up, Louis, hurry up.
The bubbles are convection. And the touching is conductive.
This for notes, so it could be two answers.
Yes, we're going to go over it in a minute.
So it could be two answers.
There's a couple of them on there. Let me show you.
Well, number one is action. Heat is invisible and weightless, right?
The thing says it isn't heat. Hold on. It says heat is an invisible, weightless fluid. Heat is not a fluid. It's not matter. So the first one is an and.
Oh,
All right, is that what you were asking, Carl? Okay.
I'm trying to help them with you.
Okay. All right. Has everybody had a chance to try them all? Can we look at some answers? All right. Number one. We already did number one, but apparently some of us are still arguing about it. All right. Number one is N. Heat is not matter, so it's not a fluid. It has no weight. Okay. So number one is N. Number two. Heat is a substance called caloric. Did we talk about that? No. All right. Heat is made up of molecules. No. Heat does not matter. If heat does not matter, Heat cannot be made of molecules. Okay? Only matter is made of molecules. So I know half of you probably said H there, so we erase it and change it to N. It's okay. Most people do. Every year, most of my students put H
I
there,
got mad.
so it's okay.
Wait for which one?
Number 3. Number 3 is N. Heat is not made of molecules because it's not matter. Number 4. Heat moves from the warmer object to the colder object.
True.
That is H. Correct. Number 5. Heat can be transferred in only one way.
No.
No, that's an N because it can be transferred how many ways? 3. Number 6. Heat is a form of energy.
Yes.
That is true, so that's an H. One of the 5. Number 7. Heat is caused by the internal motion of the molecule.
No. Yes.
Yes.
Oh, wait, what?
I guess that's good.
Yes.
H is correct there.
Because the molecules be going all crazy.
That's right. And the more you move, the more the molecules move. So right now, John's got his arms in his shirt because his molecules have slowed down. He's cold. But if he goes and moves around some more, his molecules are going to move faster. His arms might come out of his shirt because he's going to get warmer. All right? 8. Motion produces heat. The more you move, the warmer you get. When Davey goes to football practice today, he's going to move around, he's going to get hot. All right? Cold molecules move faster than warm molecules. The cold molecules move faster than warm molecules?
No.
No, that's an N. What do you ladies do?
I just want to say, hey.
Hey, how are you?
Yeah.
Number 10.
No.
The hotter a substance is, the less energy it has. No. What was what? 8 was yes, 8 and 9 was no.
What was number 8?
10 is the hotter the substance is, the less energy it has is a no. Would y'all listen?
H, son, H.
Tired of going back and reading these things again. I don't have the answer key in my hand. Number 2. Air was a what? An insulator. Number 2, copper wire.
I was going like, right.
Oh, you want me to go straight down?
Yes, I was.
Okay, so 1 was an insulator, 3 rubber.
Aye.
That's an insulator. 5 aluminum.
Aye.
Aluminum's a metal. Y'all have aluminum foil?
C.
Conductor.
Thank you, Jesus. I even had.
All right, iron. That's a conductor. And plastic. That's an insulator. All right, now the second column. So back to copper wire.
C.
See, that's a conductor. Glass. That's an insulator. But most people know if glass is heated, it's going to get hot. But I'm telling you, the answer for the test will be insulator. Silver.
C.
See, wood.
I.
And notice down. A lot of people don't know that down is actually feathers. Okay, a down comforter. A lot of people buy down comforters and they don't know there are feathers in them. Down.
I have one and I kept pulling feathers in.
Yeah, it's feathers. All right. Number 1 at the bottom
Oh, yeah.
is what kind of heat trace?
Radiation.
Not gonna do that.
Have you lost and take a leave of your senses?
Now it's giving airflow back.
You belong up here, right here, this chair, with your book bag, and you need to stay in it. Number 2, the dummy who's touching the iron. Conduction. The turtle laying on the rock. Can really have 2 answers.
Radiation.
Most people, when they look at it, think the turtle's sunning themselves, so I always take radiation. But they're really trying to illustrate that the turtle is laying on the rock. So the rock is warm, so they're trying to illustrate what? Conduction. Number 4, with the arrows, with the air coming out of the vent is convection. All right, number, I guess that's 5. With the ice cube in the hand. Conduction. The blow dryer, that's convection. Hair dryers are convection. All right, number 7 has 2 answers. You can put convection because the bubbles, hold on and stop hanging up while I'm talking, is rude. And the flames are touching the flask, so you could have put what? Conduction. You could put conduction or convection on that. The toaster, it depends on the type you have. If it just lowers and nothing touches the bread, it would be what? Radiation. If you have the kind that grips the bread and lowers, it would be what? Conduction. All right, put my calculators up and you don't have any homework.
Oh,
Get my calculators in the tub.
No.
Then